Hey everybody, so this is exam question 3 from the fall 2016 Gen Chem test at Rowan College at Burlington County. And just so everybody knows, this test was taken right from an AP question. I think I got rid of one of the parts, but this is an AP chemistry question. Okay, so let's set this up here. Let's go here. Okay, so this makes it editable, so I can write on it. Okay, it says using the equilibrium concentrations given above, calculate the value of the equilibrium constant for the reaction. Keep in mind there are always just two types of equilibrium problems. Find the constant and find the conditions. So this is find the conditions, or find the constant. Okay, find the equilibrium constant. So for part A, we want to do K, and we're going to do Kc because we're given concentrations equals the concentration of the products. I have to find the reaction. So CO and H2O. Okay, so it's the concentration of H2O times the concentration of CO over the reactants. And the reactants are CO2 and H2. Okay? That's only part of it. The other part of the problem is plugging it in and determining what the concentration or what the equilibrium constant is. And so we are given these values, and all we have to do is plug it in and chug it, plug and chug. So this equals, let's see, the concentration of H2O is 0.45. The concentration of CO is 0.45 all over 0.25. Let's see. CO is 0.30 and H2 is 0.25. Okay, and so when we do this, we do 0.45 times 0.45, okay, divided by 0.3, divided by 0.25. And when we get that, we get an answer of 2.7. Okay, so now for B is determine Kp in terms of Kc. So Kp equals Kc RT to the delta N. Okay, so Kp is what we're looking for, and that equals 2.7, and then R is 0.0821 times temperature, and the temperature is, let's see, we'll go up and find it. The temperature is 1500 Kelvin. Okay, so that's, I get rid of this guy here. Okay. The temperature is times 1500 Kelvin. Okay, and that's to the delta N. Now, delta N is the change in the number of moles, so it's the product moles minus the reactant moles. So we have to use the balanced chemical equation. So how many product moles do we have? Well, there's one here and one here, so that's 2 on this side. And how many reactant moles do we have? We have one there and one there, and so that's going to give you 2. So delta N equals product minus reactant moles, and so that's 2 minus 2, so delta N equals 0. Now that makes everything really easy, because when you do this math and raise that to the 0 power, it's equal to 1. Okay, so there's a little shortcut in the math here, that this all equals 1. And so this is then, the answer is going to be 2.7. So Kp equals 2.7. Now the last problem, okay, the last problem can be a little tricky if you get stuck in with the 5% rule. but we'll look at it. And so here it says 0.5 mole, and this is a typo. This should be 1500 K. That way the temperatures now are the same here. Okay, and so now what we're going to do is let's see, if we're trying to determine what the new equilibrium concentrations are, well, we have an equilibrium constant, so we have to find the conditions. Two types of equilibrium problems. So we're going to do an ICE chart. So CO2, let me put that at the top here, CO2 plus H2, and I'm just rewriting the equilibrium reaction from above, that way we can do it a little better. Okay. Now, what does it say? It says we have 0.5 moles in a 3-liter container and 0.5 moles in a 3-liter container. So, and that's for CO2 and H2. So 0.5 moles in a 3-liter container, that equals 0.5 divided by 3, that equals 1.67. So let's fill this out here. So this is 0.167. And that's for both CO2 and H2. H2 will have the same number of moles in the same volume, so 0.167. How much of this do we have? We have 0 and 0. Okay. And now we can do our minus x plus x plus x. And then that's 0.167 minus x, 0.167 minus x, x, x. Okay. Now, to solve for x, let's make sure we answer it. It says, calculate the equilibrium concentration of carbon monoxide in moles per liter at this temperature. So we want to determine what x is. Okay. So we know that Kc equals 2.7, which is going to equal the products, x and x, over the reactant, 0.167 minus x, 0.167 minus x. Okay. And so to simplify that, that gives us x squared over 0.167 minus x squared. Now, why do we use the 5% rule? We use the 5% rule to make math easier. Okay. Other than that, if we can solve it normally, that's fine, and look at what we can do. Can't we take the square root of this side? Square root. And if we do it to that side, we do it to that side. So the square root of 2.7, okay, is equal to 1.64, and that equals x over 1.67 minus x. Okay, and now we can combine like terms. We can multiply this up. Okay, so we get 1.64 times 1.67 minus x equals x. Okay, so now we use the distributive property, 1.64 times 1.67, which is going to be somewhere around 2.7. Okay, so this is 2.74 minus 1.64 x equals x, and now we add so we add 1.64x to this side, so it's 2.74 equals 2.64x, and then we divide. And when you divide, you get 2.74 divided by 2.64, and that equals 1.03 equals x. Now I get it. Okay, this number doesn't make sense. Okay, so But if you followed the math and got a number somewhere around there, and not using the 5% rule, I think that that's okay. Okay, so, you don't need the 5% rule in this problem. You just need to do the math, and in this case, the math is set up fairly straightforward. Okay, so that's the question number 3. Have a great day.